Hello, in this video, we're going to learn about enthalpy and how to write thermochemical equations. So the heat content of a system, or the total energy in the system, is commonly measured through the change in heat. The enthalpy of reaction delta H, the delta over here refers to the change in enthalpy. So the symbol over there denotes the change, and the symbol of H, that is the enthalpy. Therefore, when you have them together, you would say that that is the enthalpy change associated with a chemical reaction. So what about standard enthalpy? Standard enthalpy is the enthalpy change for a particular reaction that takes place at a certain standard state. In this case, it will be at the temperature of 298 Kelvin and 1 atmospheric pressure. Okay, so when you are going to be differentiating between enthalpy of reaction and standard enthalpy of reaction, for standard over here, it will happen at standard state, and the standard state is for that temperature and pressure. Okay, so remember, the standard state is referring to a certain temperature and pressure. Now, how do we write thermochemical equation? In thermochemistry, when you want to talk about the enthalpy change, it's very important for you to know how to write and to get to know the thermochemical equations. For example, right in front of you on your screen, so this is an example of a thermochemical equation. What you have over here is H2O solid, okay? It converts into H2O liquid. So what you see here is a process of a solid water changing into liquid water. So you are absorbing heat because you want to melt the solid water right over here. That's why you have the change in enthalpy that is endothermic. You have a positive sign in front of there. So this information that you see right here on the right hand side of this thermochemical equation, this is telling you that the process from solid water into liquid water requires the system to absorb energy. Okay, so this is the example of thermochemical equation. So what we need to have for thermochemical equation, it's important for you to have the phases. Okay, so the first thing that you need to know that for thermochemical equation, you must have phases for all of the species involved in the reactions, both in reactant side and product side. So you have to get the phases correctly. So that is very important. And second thing that will be emphasized for thermochemical equation is this bit over here. You need to have the value. You must have the value for change in enthalpy. If you do not have this piece of information, even though you have the phases written correctly, that equation will not going to be regarded as a thermochemical equation. And also, most importantly, always remember, okay, make sure the equation is balanced. Okay, you need to have a balanced chemical equation, and the phases must be written down, and you need to have the delta H information written down together with the balanced equation. So how do we interpret? So how do we read the thermochemical equation? So simply the thermochemical equation is telling you that 1 mole of this liquid water is formed. Okay, 1 mole of that is formed. So you have 1 mole over here. This is what you see over here. You have 1 mole is formed from another 1 mole. Okay, another 1 mole of solid water right there. So that's how you're going to read that. And what happened? You have the reaction absorbs energy. How much? 6.01 kilojoule of energy. So the reactions here is absorbing the heat from the surrounding into the system and to melt the solid water into liquid water. This is the example of endothermic. Okay, so that is endothermic reaction, because you have heat absorbs from the surrounding into the system. Now, what happens if you have the equation to be reversed? If you look now, you have from liquid water and you want to convert that into solid water. So this is just the reverse of what we have over here. So this one is from solids H2O into liquid H2O. And the one that we have over here from liquid into solid. So if you have the thermochemical equation reverse, what happened to the value over here? The magnitude will be the same. Okay, you will still have 6.01, but this time, because you reverse the reaction, what we have here is a reverse reaction. This is being reversed. So reversed from what we have over here. Okay, from what we have over here. So what happened to the delta H? The magnitudes will be the same. Okay, the magnitudes, the number will be the same. Still 6.01 kilojoule. But this time, instead of you have positive in front, you'll have it negative 6.01 kilojoule. Different from what you had here. You have positive because you need to absorb energy in order for you to melt the solid water and to make it to liquid water. And when you reverse the reaction, the value of delta H will also going to reverse. So that is what you need to know. Okay, so when you reverse the reaction, the value of delta H will be reversed, but the magnitude will remain the same. Okay, so just to recap on how to write a thermochemical equation, the first thing that you need to have, the one that we have talked about just now, make sure you have all of the phases. Okay, number one, it's very important for you to have the phases. And then second, you need to have the value of delta H. And of course, this chemical equation over here, always remember that they are balanced. So that's how you're going to write the thermochemical equation. It's very important for you to have a thermochemical equation, because if you do not have this, it will be a problem when we reach to problem-solving kind of question afterwards. Now, before we're going to end, let's have a try on this very short exercise. So which one of these equations that we have in black box, in blue, in red, in green, in orange, and in purple, which one of them is a thermochemical equation and which one of them is not? Okay, let's have a look. So I'm gonna change that. Okay, so let's have a look at the one at the top over here in the black box. You have the chemical equation, so it's balanced. Okay, check, make sure it is balanced. You have one carbon, 4 oxygen and 4 oxygen on the other side. Same goes to the hydrogen. You have all the phases written correctly, and you have the delta H right there. So therefore, the black one over here is a thermochemical equation. And what about the one in blue? So the one in blue, you have the phases, but it does not have delta H. Therefore, this one is not a thermochemical equation. And the one in red, you have the phases, okay, and you have the equation balance, you have the delta H. This is a thermochemical equation. When you look at the green one over here, the one in the green box, it has a delta H, but it does not have all the phases. Therefore, this one is not a thermochemical equation. Same goes to this one also not a thermochemical equation because you do not have the delta H value at the back. Okay, what about the one in the purple box right over here? So you have the phases and the equation is balanced. You have the exact same number of carbon on both sides and the exact same number of hydrogen on both sides and also oxygen. And you have the delta H. Okay, so over here you have the standard enthalpy of combustion. Okay, so you have the delta H value. Therefore, this is indeed a thermochemical equation.